told you to solve different than the book?
Yeah, I think this one was supposed to be.
So I said solve in radians and the direction said degrees. Okay, so what we're going to do is we're going to do the inverse sine of a third. Let's see, mode. Put your calculator in radian mode as opposed to leaving it in degrees and then converting. That's just, I don't want to say it's lame, but you're spending more time. So we're going to do inverse sine of 1/3 in radians. And it's going to give you something. The first answer, the first decimal answer that I gave you. Point. And of course, I didn't necessarily tell you what to give it to. So 0.33983. Did I do it two digits? 2 digits. So 0.34. Don't round when we are looking for the following angle, or the second angle, I should say. So this right here is about 0.34. In radians, we want to think that this is pi, and we're not going to use 3.14 for pi. We're going to use the pi button on our calculator, and we are going to say this right here, the reference angle is 0.34. So the angle that we're looking for is pi minus 0.3398, blah, 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 blah. So in which case, what we want to do is use the pi button on our calculator and then access our answer button. And then you're not rounding in the middle of the problem. So pi minus the answer equals 2.8017557. Wow, that's wonderful. 2.80. And then, of course, cosine equal is 0. Honestly, when we did these quadrantal angles, we did it two methods where you could, pick a point and use that. This is 0 over 1 is x over r, and you could do x squared plus y squared equals r squared. You could do the crazy triangle that doesn't exist, and so I go up and I go down. So I create my triangle. It kind of smushes right up against the y-axis. The only thing is that I could also be down this way and still be 0. So those are two ways. If you solve this, you get 0 squared plus y squared equals 1. Here, it does help for you to say y equals plus or minus 1, giving you the positive and the negative, which means that my angle, be careful, this x here is the x ratio of the triangle, that's our angle. So x is pi over 2, 3 pi over 2. At this point in time when we were doing quadrantal angles, and I want to say section 2.4, we hadn't talked about the graphs. You could also say to yourself, well, my cosine curve is 2 pi, which means I'm going to be 0 here, and halfway is pi, and this is pi over 2. And halfway between pi and pi over 2 is 3 pi over 2. So if you hate that, and if you hate the cruddy triangle that doesn't exist, you could go to your graph. The other way that I kind of do it is cosine is x over r. So on the x-axis, cosine has a value of 1 or negative 1. On the y-axis, x is equal to 0. Okay, well, angles on the x-axis are 0 and pi. Angles on the y-axis are pi over 2 and 3 pi over 2. And you can do just the reverse thought process for sine. However you want to be able to determine your quadrantal angles, that comes up a lot because that type of factoring is super easy. So you're going to get solving sine x equals 0, sine x equals 1, cosine x equals 0, cosine x equals -1, that kind of stuff. So just be careful. Cosine is +1 only at 0, and it is -1 at pi. It's not both, unless you're solving plus or minus. All right, so that's 47. Oh, I didn't want to do that. Okay, so. Besides number 41 on 4.1, what else do we have to do? Let's see. Let's take our screen up. You guys haven't done it, I know. All right. 41. Okay. This is what, actually, you know what? I'm not going to deny you the opportunity to do this on your own. So rather than doing 41, I'm going to do number 40. And then, Patrick, if that doesn't help you, then I'll help you on number 41. All right, so we're going to look at number 40. It's going to be, well, it's semi-like 41. Okay, so you really have got to be super careful about the wording of the problem. You've got to draw a picture, and the wording to or from is going to be super important. So I got 2 fire lookouts are located on mountains 20 miles apart. I can't draw them yet. Okay. Lookout B is at a bearing of south 65 degrees east from lookout A. Okay, so lookout B is at a bearing of this from A. So when you go and do this, you're going to do the bearing. Okay, sometimes it's good to kind of, let's see, well, let's switch that up a bit. Sometimes you don't really know where is the best place to start drawing on your paper. So, from here, we're going to go, with respect to south, we're going to rotate 65 degrees toward the east. So remember, with your bearing, you have to start from either north or south, and you rotate toward. If you start east and rotate toward the south, you're not doing it right. So we're going to start from the south, and we're going to go toward the east 65 degrees. Okay, so that means we're going to be somewhere along here. Now, it's super important. You cannot just put B over there and A down there, or A up there, or A down there. You've got to be really careful about the way the question is worded. Lookout B is at a bearing of from A. Or if we reverse the sentence, from lookout A, I can find lookout B based on this bearing. Is everybody kind of getting that A is here and B is down here somewhere? Sometimes it's not good to put a point because they're going to give you more information. So B is down here. Let's just kind of, we put it somewhere, or we'll just continue reading. All right. Also, it's great to read the problem through, but when you're trying to draw the diagram, you kind of pretty much have to dissect and follow the sentence by sentence to see what's going on. All right, so Let's see, look out B is bearing, a fire is sighted at a bearing of this. So my fire is at a bearing, whoops, lost an A, of, where am I? North 50 degrees east from A, and the bearing is at a bearing of north 8 degrees east from B. Okay, we also know that A and B are 20 miles apart. Okay, so from A, I am going to draw that bearing. I already have my grid marks, my north, south, east, west going. So from the north, we are going to rotate 5 degrees. 50, thank you. I was pretty worried about being way up there. All right, 50 degrees toward the east. So somewhere along this line is my fire. I don't really know where it is, and I can't draw it yet, because what's going to happen is I'm going to start from B, and I'm going to do the bearing here, and I'm going to say along that path or this path, whichever way we're going, that's where the fire is going to be, because we're going to have to intersect them. Does that make sense? Okay, so let's see. So we are going to go towards, so let's, sure, we can leave B right here. Now, my bearing is from B. I am not going to do this over there by A. So from B, I'm going to use this bearing, which means we're going to rotate 8 degrees from north toward the east. We're going to go 8 degrees. Whoops, not 80. 8. Somewhere along that line is going to be the fire. So we have to make them intersect. Right there is my green fire. Here, we'll make it red. Oh, just see all the flames in California. Look how it looks bad. The wind was awful too. Okay. Anyway. Half the battle with these problems is getting picture drawn. Does everybody understand how I can't just guess? I really got to go looking at the word, and I got to think, sometimes rearranging it. I've got to start on the back end. From A, we're going to do something to find B. Okay, here the fire is, a lot of times we like is equals, but here we want to say from A, we're going to go this bearing, and when we do that, we can locate fire. Same thing, from B, which is not A. B is in a different spot. From B, we're going to do that type of angle measureness to locate our fire. Okay, so we're good? The rest of all this is, I've got a triangle, which is fabulous. Okay, you cannot assume, there's one of your homework problems, it's going to look like it's a right triangle, or that it's completely horizontal. You cannot assume it's horizontal. Okay, we need angles. Okay, oh dang, I didn't label this one. This was 50 degrees. All right, you're going to make use of your northeast-south grid lines because they make what kind of angles?
Quadrantal
right
angle.
angles, okay? I would like, maybe, this looks like I'm going to be possibly able to do. You can do it however you want. I don't care. You can say 180 minus 50 minus 65. You could say, well, if this is going to make a right angle, this part here is 40 because I'm going to subtract from 90, and this part here I guess is 25 because I'm going to subtract from 90. However you want to do it, use your right angles to help you create the angle measures of the triangle. You know what, I'm going to go blue. So this is 65. Okay, I don't know squat about the fire. So, wow. Okay, but somehow I probably should be able to figure out something with respect to that B. And you know what is so awesome? I know you remember your geometry theorems like the back of your hand. Okay, so if you don't remember your alternate interior angles of two parallel lines when cut by a transversal are equal, take your grid lines, your north, south, east, west grid lines, and connect them and make right triangles. Okay, because that's 90, this is 65, and I know 65 and this angle have to add up to 90, or 90 and 65 subtract from 180, whatever you want to do, I don't really care. I had 25 over there. Now, is 25 part of the angle I want?
No.
Bummer, but guess what? It's going to help me because that other part over here is now 65 because I'm making a right triangle. That part is conveniently 8, so there we go. We take 65 and 8 and add them up and you get 73. Yes?
Yes.
Okay. On your test, you are going to have problems that need the law of sines and problems that need the law of cosines. So you're going to have to ask yourself, what information do I have and what am I going to use? Right now, all we know is law of sines. Okay, but who remembers the important pieces of information that are super helpful to have and use the law of sines?
Two angles inside. Or, sorry.
The same angle and the opposite.
You have an angle and its opposite side. Now, if I have two angles and a side, the included side, we can use the law of sines. So you're kind of didn't necessarily answer. I shouldn't say you answered it great, but if we get less technical and we just focus on if I have an angle and its opposite side, we're in business to use the law of sines. Kind of bummer. I got 73, but do I know its opposite side? I got 65, and I don't know this. So what am I missing?
Can figure out the top side.
I got two angles. I know that one for sure. Okay, so we can actually figure out this one. We're going to add up 65 and 73. And yeah, write it correctly, and you get 138. Yes, is that true? And if we subtract that from 180, and you know it's not supposed to be negative, we end up with what? 42? Yeah, 42. You know what? You're videotaping this. I'm not going to look at it. Okay. So, anytime you have two angles, you have the third angle as well. And now we have an angle and its opposite side. Law of sines is awesome. Okay, so we're going to say the sine of 42 over 20 is equal to, oh, hey, I don't even know what we're looking for. Let's go back and read the problem. Guess how many times you should read a problem, a word problem?
As many times as you need.
Oh, that is a fabulous answer. Okay, do not expect to be able to read the problem and know exactly what you're supposed to do. You're probably going to have to read it 2 or 3 times. And after you've got all this, make sure you answer the question they're asking. Find the distance of the fire from lookout A. So we want that distance. So that's kind of helpful if we set our information up so that we'll find it and then we don't have to actually kind of do more work. So the sine of 42 over 20, we're looking at 73 and x. Now, I don't really particularly focus on which way is it best to write my fractions, okay? It'd be a lot easier if you wrote 20 over the sine of 42 equals x over the sine of 73, and then you don't have to cross multiply, blah, blah, blah. I just always set it up and just do the little bit of math. It takes me an extra 30 seconds, not so bad. Okay, so You either cross multiply or you multiply both sides by 20x. I don't care how you want to think about it, but eventually you're going to get x, the sine of 42, equals 20 times the sine of 73. Make sure x and 20 are coefficients of the trig function. Okay, this cannot get multiplied in ever. Never. I want to solve for x, so I'm going to divide by this wonderfulness. Okay, again, this test you have a calculator. Your final exam you probably won't. So, if this was a final exam question, you would leave your answer as the 20 times the sine of 73 divided by the sine of 42. And you'd be done. However, we are going to punch this up and be careful. Since we have this times this divided by that, we actually don't have to worry about order of operations too much. You can really say 20 times the sine 73. You do need to make sure you are careful about it being in in degrees. Close your parenthesis and then hit divided by the sine of 42. And also, my degree measures are to the nearest degree. So our rounding convention, which is not generally just for this textbook, it is a rounding convention. We are going to give it to 2 significant digits. So this, Patrick, might be what you might have had a question about, because there's going to be a problem in here that you're going to get 364 or something like that. And the answer in the book gives you 360. And the reason is because the angle measures were to the nearest degree. Because when we give it to the nearest degree, we give it to 2 significant digits. 2 significant digits is not 364, it's 360. So I don't know if that's problem number 41 that you were experiencing, but if you have a calculator, you want to punch that up.
But if it was 365, it would have been
If it was
37.
365, it would be 370. Yeah, and has to do with, not giving a more specific answer than your measurements allow kind of business thing. I'm sure you guys have talked about that a ton with your science classes, yes? Of course. All right. So this is 14.768. So 14.768, blah, 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 blah. We have to give it to 2 significant digits because of the rounding. You need to know that. There's not a question, you just do it. So it's 15. 15, I think they said 20 miles, so it's 15 miles from the fire. All right. I'm going to leave that. All right. Let's see. I just want to talk about for all of about 60 seconds. Unmute. Oh, dang it. Maybe I won't. All right. You know what? Forget it. I won't use the computer. Let's see. Let's just shut this down. Okay. I just want to visualize for you, or help you visualize, the ambiguous case of law signs. Okay, so if you have 2 angles and a side, just like Sawyer kind of mentioned, and actually if you have any 2 angles and any side, it works. Okay. Where you're solving, or solving for that side length. When will we have the ambiguous case? Is when we have the reverse information, we're solving for an angle. So the ambiguous case is going to happen when we have 2 sides and 1 angle. Okay, in fact, it's not just any angle, it's an unincluded angle. Okay, so you're going to recognize, or we're going to talk about how if we have that situation, you know, if we know that this is 7 and this is 12 and this is 50 degrees, I can't figure out anything for that triangle with the law of sines because I need an angle and its opposite side. I have an angle, but I don't know squat about its opposite side, and the Pythagorean theorem only works for right triangles. We don't know that, but this is a right triangle. I've got 12, but we don't know squat about that. We don't know squat about that. So if I have two sides and an included angle, this right here is law of cosines. So unincluded angle is when we have this angle, this side, and that side. Okay, and since I don't know what this angle is, guess what? It's a little pendulum. Okay, so if I know this side, here we'll call it side 1, we'll call it this side. Oh, it's like thing 1 and thing 2. Sorry. Okay, when can I have no triangles? That means this side is not long enough to intersect the ray of the fixed angle that we have. Okay? Okay, so we're just all focusing on side 2. Okay, so it swings and it just never hits. We'll make it shorter just so that it really doesn't hit. Okay, so this is producing 0 triangles. Okay, I got my fixed angle that I have, and I have my side length here, and I have this side. This keeps going on forever because we don't know anything about that side. The side length we have can swing, really. Okay, so it can swing there, but guess what? It can swing back the other way and be right here. So one triangle is the black one, and one triangle which has the same exact information is the blue one. And this is where we would get 2 possible triangles. Just like we had on the problem we were doing over here on Wednesday. Okay, so you get 2 possible triangles, and it's because we have a fixed angle, a fixed side, and a fixed side. We don't know, we're just trying to intersect this side with the ray, and we don't know anything about this third side. So one place that we can intersect it is over here and create this triangle there, the black one. But since we don't know anything about this angle either, it can swing, a little pendulum. And guess what? It swings here. And so we create that triangle. All right, when do I get one triangle? 2 different opportunities. Probably you can think of one of them. What's going to happen when I have one triangle? When side 2 is exactly the length, it's going to be straight perpendicularly down. So it doesn't have any room to swing and hit 2 places. So I got one triangle. The other opportunity.
Side 1 and 2 are the same length?
No, it could be, but not necessarily. Side 2 is so long. I don't know if I made it long enough. Hold on. Side 2, so we have this fixed angle and that ray continues forever, so we just want side 2 to hit the ray. We got side 1 is fixed and side 2 length is fixed. So the only way side 2 is going to hit that ray is over here. If I pendulum and swing that back, it's intersecting over here, and now this angle's not in it, that side's not, well, yeah. Does that make sense? It's too long. You take that fixed length and you swing it in a nice arc, it's going to end up over here. And now I'm not in the triangle that I need to have. So why do we have this happening is because of the information that's given, 2 sides and an unincluded angle, It all comes up in the algebra, but this is a visual of why is this happening? That's because of that. All right. Law of cosines. A, B, C. Little a, little b, little c. All right, the law of cosines. C squared. Does it make sense that we would square an angle? So this is side c squared. Is a squared plus b squared almost looking like the Pythagorean theorem, but it's not. Okay. So the law of cosines is a little bit more complicated. You're going to do it enough that you're going to get it. Okay. C squared is equal to the other two sides squared minus 2 times the product of those two same sides times the cosine of that angle C. Okay, and notice all of this information here, side A, side B, side A, side B, cosine C. Okay, so just like I was kind of talking about over there, when am I going to use the law of cosines? Is when we have, if you have two sides and your included angle. Okay? Now, if I had if I had triangle cat, you might say, oh, wait a minute, those letters don't match, A, B, C. Or you had triangle, you know, MDF. Maybe you're a lumber person. You probably don't like MDF if you're a lumber person. But, okay, we can translate this. Okay? So, A is a side. B is a side. Minus 2 times the side times the side times the cosine of the included angle. And what does this all equal? The third side, you can say that, the third side. You can say it as the side opposite the included angle. However you want to verbalize it. You don't even necessarily have to write your formula down in letters. Okay? We're going to practice once with letters. So if I was going to write my answer in terms of, or excuse me, if I'm going to write my formula in terms of angle B. So this is the angle we have, so we're going to say cosine B. Cosine B is the included angle. So which two sides are involved in this mess?
C and A.
A and C. So we're going to have A squared plus C squared minus 2AC cosine B. Okay, visually, the other thing you can notice is, you know, my triangle ABC. Notice if I've got angle B, the sides are the other letters, A and C. So you could even not even draw a triangle and come up with the law of cosines just based on that. If you have triangle KLM and you want to solve cosine M, the other two letters are K and L, so those must be sides, K and L. Multiply by 2, subtract L squared, K squared, K squared, and that's going to equal what?
M squared.
M squared. Okay? Let's do a word problem, because I know how much you love those. this is problem number 42 on page 309 if you care. Developer owns a triangular lot, kind of strange, but all right, at the intersection of two streets. The streets meet at an angle of 72 degrees. Oh, it's like, what's that building in that, like you always see that city? There's a triangular building. I don't know where it is.
Square?
Huh?
Is it Times Square?
Yeah, maybe. I don't know. Anyway, so here's my triangular lot. We've got a street. I know my diagram looks really weird because here's a street. Here's my lot. Okay, so the, oh yeah, that's a great 72 degrees. Oh well. Okay, my streets meet at an angle of 72 degrees. Okay, and the lot has 300 feet of frontage along one street. And 416 feet of frontage along the other street. You know what? All these streets are kind of making my picture look really bad, so let's just erase it. Okay. Guess what they're probably going to ask you? Find the length of the third side. Okay. And once we recognize the pattern of the formula, we don't even necessarily need to write letters down. We can kind of look at the red. If I have two sides and the included angle, everything is going to help me find x. And whether you start from the left to the right, or you start with cosine 72 and work that way, it doesn't matter. So basically we take a side squared, 300 squared, plus the other side square, 416, minus, don't forget the coefficient of 2, 300, 416, cosine of 72 degrees. And what is this equal to?
X squared.
X squared. Of course, you're going to get such a super huge number that you'd probably be like, oh, I got to do something else. Okay, you've got to be careful. Resist the temptation. Who's got a calculator in front of them?
I do.
What's 416 squared?
Sorry. 416 squared?
Yeah.
17,000.
173,000.
Yes, 173,000.
I don't care, just read me the numbers.
173056.
Multiply 600 by 416.
600?
Ah. 249600. Cosine 72, I see.
Okay, yeah. So, if you are one of those people, some of you, and I don't want to say the men, but usually the men, they'll just punch this whole thing up. The ladies, for some reason, sometimes they'll punch it up too, but sometimes they'll say, I'm going to multiply it out, I'm going to multiply it out, I'm going to. So then we're going to add these two guys together. So we got 90,000. So I got what? 560362 minus 249600 cosine 72. And guess what your least favorite thing is of that expression? Cosine 72. So do you know what people look at? This minus this. And am I allowed to take this number minus that number? No! That's like taking 1 plus 2x and making that 3x. So, you know what? Sometimes it's better to just punch this all up. Okay? And then make sure you square root. Okay, so be careful. I still, yeah. Don't try to subtract these two like you're doing more work to make me happier. You just kind of, yeah. So we want to do that, and then we're going to square root. I'm going to stop there if that's okay. Oh, wait a minute. You know what? Let's just do it. Sawyer, did you punch that up before you square rooted it?
No.
All right. Well, punch it up and square root it. Because let's talk about significant digits. Did anybody else get it punched up? Square rooted?
Yeah, it's 431.19.
What are you giving our answer to?
2,
2 digits. We're looking at the 3, we're looking at the 1.
3,
3, do I make this 4? 330 feet, excuse me, 430 feet.
So are angles and sides both rounded to 2 significant
When
digits?
your angle is to the nearest degree, I give sides, so it's a kind of a
Because that
poor
one has-
question, I know. The textbook is real critical about that with respect to the answer. I'm not 100% sure whether, so this is really only has one
Yeah,
significant
it's just
digit.
on that one has 3.
I usually try to make sure I kind of give my sides to 2 significant digits when I write a problem like this, but, so I'm not that knowledgeable about, is this really a problem? But, we're gonna go by the rounding convention. All right, guess what? That relationship involves all 3 sides and 1 angle, okay? So there's actually another form of the formula. So let's go to c squared equals a squared plus b squared minus 2ab cosine c. And let's solve for cosine c. Okay, so I'm going to subtract my squared values to the other side. C squared minus a squared minus b squared. All right, I'm still solving for cosine c, which is right here. I've got this minus 2ab kind of being right in front of it, which means to get rid of it, what do?
divide by.
I gotta divide, because it's multiplying right now. Divide by negative 2ab. Okay, so I'm just gonna flip-flop sides if you're okay with that. Cosine of c is equal to c squared minus a squared minus b squared over negative 2ab. How much do you love all those minus signs?
No,
I know, it's your favorite thing in the world. Okay, so do you know how negative 1 over 2 is equal to 1 over negative 2, which is equal to negative 1/2? Okay, so that negative can float top to bottom. So it is on a product, so there is no factoring it out. But when I bring it up top, guess what I've got to do? Distribute it. Okay, so c squared is now going to be negative. So I'm going to have minus c squared. When I distribute this negative, my a squared is going to become positive, and my b squared is going to become positive as well. A squared plus b squared minus c squared over 2ab. And what does this tell me? I have a format where if I have all 3 sides, lowercase, 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 these are all 3 sides. Okay? If I have all 3 sides, I can find one of the angles. Guess which angle? The side opposite the one that's being subtracted up top, and he's so sad because he's not in the denominator too. Okay? So, I kind of make the connection between the angle that we're trying to find and the side is being subtracted is the one that's opposite the angle I'm trying to find. So we don't necessarily have to memorize all this letter. We got a side squared plus a side squared minus a side squared over 2, don't lose the 2, and then the side times the side. And these 2 are the ones that are positive, not that one that's negative. So for example, if we just had a triangle, who wants to make a triangle up? I don't care. What are the 3 sides?
7, 9, 11.
Good. It's a triangle. Okay. Which angle do we want to find? Top, left, or right?
Great.
Right. Let's call it B for Brit. Okay, I want to find B, so I'm going to write what?
Cosine B.
Cosine B. I personally put this one first. Okay, so that side opposite the angle we're looking for, that 7, that's the one that's being subtracted and squared. The other two, honestly, it doesn't matter which order you write them. We're gonna have 9 squared plus, does this make sense? And then in the bottom, the 9 and the 11, they get to show up down here along with a coefficient of 2. Be super careful if you're punching this up all at one time. Okay, because now we're mixing addition and subtraction with division and multiplication. Okay? If you're gonna punch this up all at one time, you're gonna need parentheses around this. And parentheses around this. Because if you do the parentheses around this, you're like, oh, I got that. Divided by 2 times 9 times 11. Your calculator follows order of operations. So it's got this whole quantity divided by 2. So I've got that mess divided by 2. And then guess what it does? Left to right. And now 9 and 11 show up in the numerator. Oh, bummer. Okay, so make sure you use your parentheses. All right, I didn't get a chance to talk about the area, which is, do I have this split up into 2 days?
Yes, you do.
Score! Oh, dang it. Wait a minute, hold on. Score. We don't have to talk about area until the next day.